Hey team, so we are living in the land of proportion. And in this land, we are given some scenarios, right? So these real life sort of word problems. And you can use a proportion to help you solve them and figure out this mystery. So in the directions here, we're going to be solving, and we want to remember to round to the nearest tenth or cent if that becomes a thing. So we have some info. We know that the ratio of adults to children in a movie theater is 7 to 2. So we have adults, we'll just make it red, adults, and we've got children. Dun, 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 dun. And so when we compare them, right, we can use this sort of colon. So we have adults to children. Well, adults is not actually a mystery, right? We don't need to just call it an A. We know that in this scenario, there are seven. There are 7 adults and there are 2 children. So we have a 7 to 2 ratio. We can write it in this format here. We can also write it in maybe a more familiar way, which would be as a fraction. So we could call it a 7 to 2 ratio of adults to children. So here's where the mystery comes in. So if we know that there are 26 children in the theater, we want to know how many adults are there, right? If it's proportional. So we could say, well, we know that there are 26 children. So children live on the right side of our ratio, or in this scenario, in the denominator spot. So we can say, all right, so we'll call children now 26. And we're going to want to solve to figure out how many adults. Bum, ba-da-da, that's our mystery, right? So we have set ourselves up a proportion. So you can use now what you know about solving proportions to be able to set this up further. So we can say, all right, well, we can do 7 times our 26, which we know is going to be equivalent to 2 of our mysteries, right? But we want to know what one of our mysteries are, right? We want to know how many adults there are in this proportion. So in order to get X by itself, right, we want to give them a little personal space. Right now it's connected because it's touching. We know it's connected by multiplication. To undo multiplication, the inverse or opposite um, uh, thing we can do is we can divide. So the opposite operation, that's the word I was looking for, of multiplication is division. So we'll divide by 2. 2 divided by 2 gets us 1. So finally, x is just by itself. There's only one x. Legal to do so long as whatever we do to one side, we do that same thing to the other, right? So first we may want to do our 7 times 26 to combine those like terms, which gets us 182. So 7 times 26, we don't need to call it that anymore. We can call it 182. So now we can divide it by 2. We can use a calculator if we want to get 91 is equivalent to 1x. So in our proportion, we can go back to our original physical setup. We can go back to our proportion over here, and we can say, all right, x, you're no longer a mystery. We're going to call you 91 adults. Okay. And you can see if it is equivalent. You can see if it does work, if you've done it correctly, by checking your work. So you can do that in a couple different ways. You can simply say, is 7 halves equivalent to 91/26 by thinking of these as division problems, right? Because we know that all a fraction bar is a division problem. So you can do on your calculator, if you want, you can do 7 divided by 2. Oops, not 72, but 7 divided by 2, which is 3.5. And when you do that same thing, 91 divided by 26, you'll see you also get 3.5. So you can say, is 3.5 equivalent to 3.5? Well, yeah, it is. So there's 91 adults.